Non-linear data structures are data structures where the elements are not stored sequentially. If you want to know about the data structures that store the elements sequentially, just click on my other video where I explained linear data structures. In this video, we will be talking about nonlinear data structures, and just to recap, if you don't know, there is one basic data structure that is called a node, where you have a value and a reference or pointer to another node. If you have a node with a value and a reference to the next one, then you can build a linked list, and with a linked list, then you can build a queue or a stack or these type of data structures. But what if instead of having one pointer, you have multiple pointers? If you do that, then you can have new nonlinear data structures. If you put certain rules on top of that, then you can have what we call a tree. For example, if we have a node and the node has multiple pointers, but the pointers cannot be duplicated inside of the data structure, and no node points to the head, then we have a tree. So you will have something like this. And then on each of them you can have, on each of the nodes you can have more things. So the head of the list in this case, since it kind of to keep a similarity with the tree, it will be called the root, and they don't have any reference or they have null references, then they are called leaves. And depending on the rules that you put on top of a tree, then you have different type of trees, and you can have different type of usages that you can do. So for example, if the number of levels between, like the number of basically references from the root to the last node are similar between all the leaves, then you have balanced trees or unbalanced trees. If they are sorted, then you can have order or unorder, and then you can have different type of specialized data structures based on trees, like heaps or AVL or red-black or binary search trees. If we remove rules on top of a tree, then we could end up with a graph. Imagine that you have a tree where you don't care about duplicating pointers, or you don't care about no one referencing the first node. So in that case, you start having a graph. So a graph is basically, you can have this type of structures where it's column 1, 2, and 3. The references from the node number 1 are referencing 3 and 2. From node 2, we are referencing 1 and 3, and so on. We can have multiple things. We can even have multiple pointers between different nodes. In the case of graphs, nodes are called vertices, and the references are called edges. Depending on the rules that you apply on top of that, then you have different types of graphs. So for example, if you only have one reference from node 1 to node 2, but you cannot have from node 2 to node 1, then it's a directed graph. If not, it's an undirected. You can also have value on the edges. If you have values on the edges, then you can have weighted graphs or versus unweighted graphs. And then, of course, depending on that, you can apply certain algorithms. So you will see a lot of algorithms being applied or not, depending on the type of graph that you have. You can see that many data structures are built on top of others, just adding or changing the rules. You can either reuse them or change how you access or operate on the data structure, and then you will get new ones. But so can you think about a data structure that maybe uses a lot of the other data structures and access the data differently? Keep watching if you want to know more about it.